So in this video we will be talking about unit vectors. So unit vectors are vectors that basically are only used to show direction and have a magnitude of 1. So when we specify unit vectors, we have I, j, k. I basically specifies the x-axis, j specifies the y-axis, k specifies the z-axis. In this video we will be looking at the two of them. The basic notation of I is 1, 0 because it only shows the x-axis, and then for j the notation is like this because it shows y-axis. So let's talk about norm vectors. So when we look at norm vectors, we need to look at position vectors. So for example, if we have a point A and then B, the norm vector will just be AB, in which the coordinates of A are subtracted from B. Let's look at this with an example. If we have A is equal to 3, 4 and B is equal to 2, 1, then it would be AB will look like B minus A, right? So 3 minus 2 comma 4 minus 1. In this case, it would be 1, 3. Okay, so that's the easy way to do it. So basically, a norm vector can be defined as a magnitude of a unit vector. Yes, I did see the magnitude of a unit vector is 1, but if it's accompanied with like other coefficients, like for example 3i plus 2j, if we want to find the magnitude, it won't be 1. It will be something like, it's just going to be in the square root and then position vector squared, or just x2 minus x1 plus y2 minus y1. So once we identified the magnitude of a unit vector and also its standard form, which is like I plus j or minus j, the standard form, and also the magnitude, to find the unit vector of a coordinate system, the thing that we need to do is just the unit vector, which is this one, over the magnitude. And then for each magnitude, we're just gonna use for each unit vector, we're gonna use the magnitude as the denominator. So for parallel vectors u and v, u equals kv. This is because, for example, if it's pointing this direction, then if we multiply it by k, it could either decrease the size and make the direction the same, or increase the size but change the shape, the direction to the opposite direction. So if k is negative, then it will change direction. If it's positive, then it won't. It will stay the same. So for example, for two vectors u and v, they are equal if their corresponding components are equal. For example, 2i plus 3j plus 2i. So as you can see, the I values are the same, the j values are the same. So to know if two vectors are parallel, all we need to do is just find their slopes by using the formula changing x, changing y. If they have the same slope, then they are parallel. If not, they're either perpendicular or intersecting at one point. Okay,